Hello, welcome to today's lesson on further maths. Today we'll be talking about permutation. But before we continue, I would like us to take a quick review of our previous lesson. Okay, welcome back. Now, from what you can see in front of you, what is the word permutation? Permutation talks about the number of arrangement of objects. Now, when we want to talk about how can you arrange something, if I give you two spoons, and I say place it on these tables, I gave you two tables. It is either you put spoon A here and B here, or you put spoon B here and put spoon A here. So how many ways can you arrange it? You have only two ways. The first way is either you put the first A here and put B here, or you put B here and put A on this table. So you have only two ways of arranging these two spoons on two tables. Now we can also move further to say, if I give you the letter of the words, let me say A, B and C. I say go ahead, arrange these letters for me. Just arrange it the possible way you can arrange it. You discover that you can have A, B and C, which is very correct. You can have A, C and B, which is also correct. You can as well have B, A, C, which is correct. And you can as well write B, C, A, which is correct. You can go ahead and write C, A, B, which is also correct. And you can still write C, B, A, which is correct. Now check, apart from this 6, 1, 2, 3, 4, 5, 6, that you can arrange this thing. There's no way you can arrange this thing again other than this. If you want to write BCA, you already have it, BCA. If you want to talk about ABC, you already have it. If you want to have B, in short, anywhere you want to arrange it, you already have it. So you have 6 ways of arranging this. But when you had two spoons, you had only 2 ways of arranging it. Now, if you watch how it progresses, you discover that the number of ways you arrange a given item or subject is the number of that thing downwards. For example, when I had ABC, 3 numbers, I made use of 3 times 2 times 1. When it was just 2, it was 2 times 1. You start from that point of the number of elements and you start multiplying downwards. And when you multiply this, like in permutation, when you have 4 times 3 times 2 times 1, it means you're multiplying from 4 downwards. If you have 15 downwards, it means 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. So, and this is called the symbol. The symbol is called factorial. This symbol is called factorial. So when you have 3 times 2 times 1 is equal to 3 factorial, which is the same thing as 6. When you had 2 times 1 is the same thing as 2 factorial. 2 times 1 is the same thing as 2 factorial, which is the same thing as 2, because it's 2 times 1. 3 factorial is 6. So 4 factorial is 4 times 3, which is 12, times 2. 12 times 2 is 24 times 1, which is the same, 24. Then if I want us to do 5 factorial is 5 times 4 times 3 times 2 times 1. So you now have 5 times 4 is what? Is 20 times 3 is 60 times 2 120 times 1 120. So the value of 5 factorial is 120, and so on and so forth. Now, if we have a number of this nature, let me say I'm giving you a number, 7 factorial divided by 3 factorial and 4 factorial. So you now have it equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, another bracket, 4 times 3 times 2 times 1. Now this is what you have. But you know when you have something like this, you see your answer is still your answer will be giving you 35. But when you next time if you have something like it, it is better when you have 7 factorial and this, you just get to a point and say 7 times 6 times, since you have 4 as the biggest factorial under here, 7 times 6 times 5 times 4 factorial, because 4 factorial here is 4 times 3 times 2 times 1, all over. You're checking what you're having under here, 3 factorial times 4 factorial, so that if this 4 factorial eliminate this 4 factorial, you now have 7 times 6 times 5 over 3 times 2 times 1, which is equal to 7 times 6 times 5 over 3 times 2 is 6 times 1 is 6. So this 6 go with this. You now have 7 times 5, which is 35. So we still got at our point 35. But using this method makes your work neater or sweeter. Now there's one question I want us to try. In how many ways can you arrange the word? In how many ways? Let's do this. Let's do another question. In how many ways can the word banjo be arranged? In how many ways can you arrange this word banjo? How many letters we have here? We have 1, 2, 3, 4, 5, 6. So if you want to arrange banjo by putting maybe A first, N first, J, U, scattering it, you have 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, and is equal 6 times 5 is 30. 30 times 4, 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720 ways. So if you want to go into arranging the word banjo, you can only achieve that in 720 ways. Okay, we are still moving further. So I want you to understand that, remember what we're doing when we had 7 factorial. So it was equal to 7 times 6 times 5 times 4 times 3 times 2 and times 1. So what we are trying to say, it was equal to 7 times 7 minus 1, 7, which is 6, then 7 minus 2, which was 5, 7 minus 3, which was 4, 7 minus 4, which was 3, 7 minus 5, which was 2, 7 minus 6, which was this, but you can't do 7 minus 7 to give you 0 and condemn everything. Now, so when you have factorial, n factorial, it will now be n, then the next one will be n minus 1, next one n minus 2, the next one will be n minus 3, the next one will be n minus 4, the next one is n minus 5, continuously to the n. That's the value of n factorial. Now, if I should go ahead to ask you, find the number of ways, find the number of ways of arranging. While I'm solving this, I want you to do it on your own. Arranging the word machine. Let's use machine. If you can pause it, I want you to even get a hold of it, solve it before confirming with my own answer. Now, when you're dealing with the word machine has 7 letters. Machine have 7 letters. So the number of ways becomes 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you do that, you have 40. So this is the number of ways you can arrange the word machine. So let's call this question number 4. Of arranging the word machine. Now we go into evaluating, but there is a single rule that controls permutation. Permutation. Equations for permutation. Let's say if you are being given 8 permutation 3, this is the same as 8 factorial over 8 minus 3 factorial. So you now have 8 factorial over 8 minus 3 is 5 factorial. Now remember the rule I give to you. Now do 8 times 7 times 6 times 5 factorial over 5 factorial. So that 5 factorial will eliminate 5 factorial. Instead of writing 5 times 4 times 3 times 1, you still come to write and you start cancelling. So just end it this way. Now you now do 8 times 7 times 6 is equal to 336. We now have our value as 336. So if I now give you 11 permutation 9, so what you need to do here is you write 11 factorial over 11 minus 9 factorial, which is the same thing as 11 factorial over 2 factorial. Wow, this should be a very large number. So now have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial, because we have 2 factorial here, all over 2 factorial. So that 2 factorial goes with 2 factorial. Then if you multiply this, 11 times 10 times 9 times 8 times 8 will now give you 19958 400. Woo! I stated it is a very large number. So I would like to say a very big thank you for being part of today's lesson. But if you want to refresh your memory on what we've just discussed, please just take the test that will be coming up on your screen. And always do well to consult the platform for better information on the topic we've just discussed. And feel free to drop your comments in the comment section. If it's a question, we are always ready to receive it from you and we'll give justice to that. So thank you, and expect to see you next time in our next lesson. Thank you.